So we'll get going with kind of preliminary remarks. I will spend a couple of minutes just kind of walking through the process for folks that are new, and then we'll dive into just kind of open mic. And then we've got Chris on the line ready to do his main presentation, which I'm looking forward to. It's on the topic of trust in AI, and he's going to cover a bunch of interesting reports in a bit of a survey format. So a couple of few quick notes. You may have seen I sent out a call for papers not too long ago, and the response has been great so far. So here's a view into the next few meetups. In May, Santosh is going to be talking about YOLO, which is a object detection system. In June, Kelvin will be talking about a healthcare application, arrhythmia detection with CNNs. And in July, Nicolas is going to be talking about quantum machine learning. So I'm kind of pumped to have the next few meetups lined up. Of course, if you are interested in presenting your favorite paper or some work that you're doing, you can hit up that URL, twimlai.com/meetupcfp, and let us know. Got it. All right.
That's why I'm downstairs.
Yep. Usually, it's sometimes it's a little bit of whack-a-mole trying to find it, but got it on the first try that time. So a couple ways for you to chime in. There's the Meetup channel on Slack, if you're on Slack. There's also the Zoom chat. From time to time, Chris in his presentation will ask for questions. And if you have a question, then just unmute and feel free to ask. If you don't want to ask, or you have a question some other time while he's speaking, just submit it via Zoom or Slack. And Chris, so you know, I'll be monitoring those, and I'll kind of interrupt you or ask questions or whatever, or save them until you ask for questions. I know it's difficult for you to monitor two chat sessions and present at the same time.
I tend to be kind of a steamroller when I get going, so just yell if there are questions you want to interject with. So no problem.
Okay. And that goes for everyone. Just
totally
chime in. So I think that is it for preliminary words. Now, right on time, opening it up for community discussion. Some of our kind of standing topics are kind of questions or comments or thoughts on recent podcasts, thoughts on topics or guests, or anything that you'd like to hear more about or from on the podcast. Just thoughts on what you're working on, interesting new papers or projects you've seen or news items, or just anything that's caught your interest since last time, or things you have questions about. Who wants to go first?
Yeah, Sam, I'll go first.
All right.
You know, today's topic is hi. Today's topic is very important because I was in Princeton 2 weeks back.
Okay.
A friend of mine specializes in LiDAR technology for autonomous cars.
Okay.
And he was saying that, you know, because cars are a consumer product, trust is very, very important because, you know, at the end of the day, if you only have, let's say, camera-based deep learning systems, which are the neural networks which are analyzing the perception function, you know, how do you actually prove that your algorithms are trustworthy if you only have neural networks in place? So I just thought, since the context was important, I'll bring it up today.
Yeah, that is a really important question and issue, and I'm sure Chris will touch on that. But it also brings up this notion of explainability and kind of the opacity of deep neural networks. They're a lot more difficult to understand why a neural net is making a decision compared to something like a decision tree that's pretty transparent.
Right.
I did a podcast on, there have been a number of attempts to try to make machine learning models more explainable. I did a podcast with Carlos Guestrin a while ago, who came up with a system. He's at University of Washington and Apple, and has a system called LIME. I forget what the acronym is for. If anyone knows, yell it out.
I think it's local interpretable something something.
Okay. So LIME is kind of a model for creating explanations from other models. And I've since then I've seen it in action in places. Like, people have told me they're actually using it. I've talked to a bunch of folks that are doing, like, they'll use the trained deep learning model, and they'll kind of use that as the labels for training another model, like a decision tree, which is more transparent. Has anyone seen or worked with that kind of thing?
Yeah, Stripe actually has done a few talks about that type of technique, where they have a really deep net that is doing like fraud detection or decision making, and then they have something like a random forest that's actually coming up with a couple of 80 reasons that usually are the reason why. And so it's like layers of interpretability, like almost like middle ground stuff. Yeah, anyways, I've seen that. It's interesting. If you look up Stripe, they have like 2 or 3 talks online about it, and they have a couple pages that they put up about it.
I'll do you one better. If you check out TWiMLAI.com/talk/73, I did an interview with Sam Ritchie from Stripe, who worked on that project.
That's right. I think that's where I heard it first, actually.
Nice.
I was trying to like furiously search whether it was there or not. So.
Yeah, no, I've seen it elsewhere since. I forget what the other places I've seen it come up, but that's becoming a popular approach.
Perhaps I just have a point to make. I was reading somewhere that in Europe, in the coming years, they are going to make any AI system which explicitly doesn't prove that it is trustworthy as illegal. So you will need to make, this is happening in Europe. Probably Chris can throw more light on that.
Right. So that's based on GDPR. Do we have any GDPR experts online, or folks that are knowledgeable about GDPR? No. So
all I know is I think they're going to be disappointed. I guess that's what I'm assuming. That's all I know. But I'm not.
Well, who's the they? Like everyone, or?
I think everybody involved is going to be disappointed. Like all the people, the companies that are trying to adhere to it. I think all the regulatory bodies that are believing it will help things, and the consumers or people that are going to be impacted by this. I think everybody's going to be disappointed.
Yeah, so Matt chimed in on that's Slack. All I know about GDPR, I learned on the podcast. Nice. So yeah, I mean, the thing is, GDPR has teeth, right? The fines are substantial, and companies are really, really scared about it. I don't know if anyone on here follows Hacker News, but there was a few weeks ago, like this, it was beautiful. It was like this GDPR trolling letter. And it's basically how to architect a request to a company with all these things that they must comply with, that would send them into like this 4-month documentation loop. It was really, really nuts. But that's the kind of accountability that GDPR is pushing onto companies. And I did another recent podcast was with, so there were 2 Robs recently, Rob Monroe and Rob Walker. It was Rob Walker from Pegasystems. And one of the things that they're doing, and I think H2O does something similar, is like these are kind of elements of what they do, at least, is like a platform for machine learning. And they have this like explainability dial or transparency dial that basically you can build models using these kinds of tools. And the idea is that tools will allow you to dial in how much transparency or explainability you need, presumably at the expense of accuracy or maybe train time or something like that. And I think H2O is another one of these companies that's using these training explainable model against the unexplainable model type of approach. Was there another comment that came in from Nick?
Yeah, I just wanted to share on subject of stuff that we're working on. I recently finished a blog post kind of exploring parallels between computer vision adversarial examples and human vision optical illusions.
Oh, interesting.
Yeah, so I shared a link to it. It's you know, it's not really a research paper. It's kind of just writing for fun. So it's interesting stuff.
And did you find is it kind of a thought piece that is drawing parallels between optical illusions and
I mean, it was kind of just yeah, it's kind of just
mechanisms.
You know, I tried to address the basics to try to as an explainer for someone who might be less acquainted.
Okay.
But also touched a little on like capsule networks and kind of speculation about, you know, what different architectures might imply for adversarial examples.
Okay, cool. I'll definitely check it out. And that's in the Slack. Why don't you throw it onto the Zoom chat as well for folks that
sure.
aren't on Slack. Awesome. Anyone want to toss in a final word before I turn it over to Chris?
No, I think this Facebook controversy has really ignited public debate all over the world.
Yeah.
So it's going to be a very important issue. Everybody's talking about it over here.
Yeah, that's true. Any thoughts on like, are there folks that you've heard in the discussion around that would make interesting podcast guests?
Yeah, if I think I'll probably email you if I get something.
Okay. That'd be great. Yeah, when it first happened, I thought, oh, the Cambridge Analytical whistleblower. But then I thought, yeah, maybe not. Yeah, but if you come across anyone that kind of knows what they're talking about when it comes to that, or GDPR for that matter,
okay.
Those have been kind of on the back of my mind to try to find some guests to talk to those issues. All right, cool. So then without further ado, I will pass the baton over to Chris, who's going to talk to us about, sorry about the wrong image here, but Chris is actually going to talk to us about trust in AI. And in particular, he's going to draw from these 4 papers. If you want to pull up the papers as he's talking to them, the easiest way is probably to go to our meetup page and click the links in the description. You may recognize this last one, the Overtrust of Robots. Ayanna Howard was on the show, and this is a paper that she worked on. So if you want to dig into more detail on that paper and her work, I highly recommend that podcast. It's a great listen. So Chris, over to you. I think I may have to stop sharing first, but you should be able to start sharing.
There we go. Can you see my screen pretty well?
Yes.
Okay, great. Cool. So I'm Chris Butler. This is my email address, my Twitter, and then this link is where all the resources and links will be available afterwards. So and also the slides. So don't worry about writing anything down right now. But you know, like Sam said, I'm going to be going through 4 different papers. There's a lot to go through because actually 2 of these papers are really overview papers of kind of the state of trust and automation. So I'm really going to try to touch on the parts that I found to be most important. I'll start off with like maybe just a quick note about what trust really is. And then what does that mean for AI in organizations? And I'll talk about what that means. And then maybe a little bit around how we start to practice the building of trust in these systems, especially from our standpoint when we build things at Philosopie. The questions you should be asking, you know, why does trust matter? What is the appropriate level of trust for machines? How do we build trust between humans and machines? How should we team people and machines on problems? And then what techniques can we use in practice to build trust? And then finally, why do I have to make so many sci-fi references during this entire presentation? So we'll get to that. So Trust 101. Really, you can go and read the Wikipedia entry. I can definitely point you to some papers that do a better job of the philosophical reasons for trust, but the reason why we have trust in society or culture is because it really facilitates cooperative behavior. It allows us to start from a main place that we both know how we should operate with each other. And I think trust is very interesting when we talk about, especially human and machine teaming, as it's referred to. And I think when we talk about this idea of, say, Google and their research around what makes great teams, psychological safety, the cornerstone of that is really trust between the people that are on that team. And I think that should extend to these types of intelligences as well. So the first one I'm going to talk about is some observations on mental models, which was back in 1987 by Norman. And so this one has a really interesting story around calculators. And so he did a lot of research around how people utilize calculators, like a for function, like this one you see in the picture, but it could also be scientific calculators, and then other types of calculators, which I had used before, but he used a lot of terminology around calculators. But the story that's really interesting to me is that there are rituals that people started to build up while using any one of the calculators. And that was, I don't know if you do this, I definitely do it, but if I'm using a calculator, I'll hit clear multiple times. And it's something that everybody seems to do, no matter what calculator they're on. And what Nora was really talking about in this case is that there are things that we understand about the technology that may or may not be true, but it's based on a mental model that we've created about them. And it's about how we trust those technologies to a certain extent. And so why do those things work, though? And so it allows users to avoid keeping an accurate count, right? Especially if you have certain levels of clearing or different memories. It actually works across all calculators. Even if a scientific calculator may have multiple memory slots, it still works. It's also resistant to slips of action or interference with other activities. So this idea that I may be clearing this multiple times, but it's because I don't want to mess up in some way, because the state of the calculator is not actually understood by me all the time. And then it generally uses and generalizes across any work that I may be doing with the calculator. And so this talks a lot about whatever our particular model is that we're trying to, the actual system itself. It's not the same thing as the user's model. It's not even the same thing as the designer's model. We talk about all these different models. And this is maybe something that I learned or really came to the conclusion of almost like 10 years ago, but, we must really discard our hopes of finding neat and elegant mental models. And I think that's very true when we talk about the way that machines work. The reason why is that we need to understand that humans themselves are going to be messy, sloppy, incomplete, and indistinct structures that people actually have. And so, I think this gets to the point that if you've ever tried to build something and you just sit down by yourself and just build out what you think is logically the best interface, it will almost always fail when you test it with other people. And the reason why is that people don't have the same mental models, or they use mental models that may not be logical. So I thought that was like a really interesting paper. He goes into much more about the calculators and a couple other stories about mental models and that type of thing, but those were really the key things for me. The next one, this is a really big paper. So Humans in Automation Use, Misuse, Disuse, and Abuse. And this is by Parasureman. Actually, I'll pause for questions for a second. Are there any questions before I move on? No? This is a pretty straightforward one. So
no question, but I will cop up to hitting the clear button multiple times.
Okay, exactly. It's something we all do, right? Because it feels comforting. It makes sense. You know what I mean? Even though it's not the real way to use a calculator. So anyways, so Humans in Automation, Misuse, Disuse, and Abuse. And so Parasureman, this is a really big summary paper. And so it's a survey of 120 papers from 1977 to 96, but it's mostly from kind of the early 90s. This paper in particular has been referenced over 1,000 times in other papers, and Parasureman is, kind of prolific when it comes to his discussion around automation, especially trust in automation and other HCI types of things. So really interesting author. And a lot of the stuff that comes out of this are actually two main, or at least during the survey, there are really two main groupings of information that comes out. And one of them is students, because, professors tend to have lots of access to them. But the other one is that automation has actually existed in a lot of different forms within aviation for a very long time. And so a lot of not only the accidents that have happened, but also kind of learning over time has come from aviation. So this is actually a fairly modern 747 cabin interior, but you can see that there's at least 5 big screens, but a lot more of other ones, right? And they're all controlling things and all have levels of automation that are able to both, that's basically assist the pilots, but, as we talk about this more, sometimes it could be overload, and sometimes it's not enough. So the first thing, use. What this really is about is really the voluntary activation or disengagement of automation by human operators. So when they say like activation, that means that they are thinking about it from the standpoint that there's not full automation that is never touched by humans, but that there's some amount of kind of like turning it on and turning it off, but doing it in a way that makes sense for humans and is the correct time to actually turn it on and off. And I would say that this is really kind of the center point for just enough amount of trust between the human operator and the system. The next one is misuse. And so misuse is where you're actually depending on the automation longer than you should. And so this is the over-reliance on automation, which can result in failures of monitoring or decision biases. And so this really gets to the fact that if I trust the machine too much, I will have it do things that are actually not correct. And so it could be that in the case of, say, like an ad buying automation, I believe it so much that I never go in to actually check what's going on with it, right? Like I never adjust the numbers. I never, even though I should go in and actually update it at some point, I've decided I trust it so much that I don't do anything. And this is, potentially part of the problem that happened with, when we talk about safety drivers and autonomous vehicles, especially the Uber incident just happened. That is probably a case of misuse where the safety driver depended too much on the vehicle.
And
disuse.
Does the paper talk about like human-computer interaction, design, decisions that influence misuse, for example? Like, is that the thrust of the paper, or to what extent is that covered?
Yeah, they talk about it a couple different ways, but I think actually one of the other papers goes into a better list of factors.
Okay.
So yeah, I would say that like I'm really just scratching the surface of these papers, so it's more of like the gist of them. But there's a lot of good stories, and they kind of dive into individual papers that helped kind of create this kind of framework that they put together. But yeah, they go into a bunch of different factors that create possible misuse situations. But I think like the later paper that I'm going to talk about has a better framework around that maybe.
Okay.
So disuse, that is really, this is something that happens when, in our case, when we talk about, the different actors within this system, as far as parser-Sermon's concerned, is that there's the user, there's the designer who creates the system, and then there's management of this, that basically sets things like policy around that. And so, disuse. I was thinking about abuse. Sorry. Disuse is just that you don't use it when you should. And so it's neglect or underutilization of automation. And so that's the case where in some cases there have been air accidents where the pilots tried to take over when they probably shouldn't have. That's an example of disuse. And then finally, abuse is what I was talking about, where when we talk about management or design, making decisions that are potentially bad for the operators, which are actually using the automation. And so in this case, automation of functions without regard for the consequences of human performance. So it could be that abuse would be that, in particular, right, the management or the designer decided to create automation in such a way that it hurts the performance of a human operator or of other users of that system without actually any regard for what is best for their job. So it could be that it creates more work for them. It could be that it creates a certain amount of distrust or too much trust into the system. It could be, and so the symptoms of this are actually misuse and disuse from that standpoint. So that's, I think, like one example I wanted to talk about here, and this is Ayana's paper, and I actually talked to her a couple weeks ago after hearing your podcast, just because I was so interested in it. But this is maybe a good segue when we talk about misuse and overtrust of robots. This is a particular paper by Anna Howard. And so this was, podcast, I think 110. This is the main part of the paper is that it was really concerning that, and I'll show you what this means in a second. Maybe I should have put the slide afterwards, but participants were willing to follow a robot even when it had recently made mistakes. And I think part of the reason for that is that, and this is a video of the particular emergency robot. And so they'd simulate an emergency situation, but not tell the people. But what would happen is that they stage different cases. This is actually a remote operated by a human being, but they would actually have it go around in circles or bump into the wall or clearly point people into this room where there was nowhere to go. And so because it looked like an official robot, and there's a lot of things that are still to be tried out when it comes to this type of stuff. They believed the robot, they followed it most of the time. Even when it would make mistakes, a majority of the time it would still follow it. It was only when it made very blatant mistakes up front would a few people not actually trust it. So I thought that was really interesting from the misuse scenario. And so like in high risk situations, people may blindly follow a robot without much regard to the content or reasonableness of those instructions. And so this is a good example of where, and we'll talk about this again a little bit more in the next paper, but how to set the right level of trust or to instill the right amount of skepticism or not necessarily even embody the system that you're building into a robot, because sometimes robots may actually cause more trust than not. And so I thought that was very interesting about this paper.
Has anyone created standards of validation for, what's trust but verify? What's the proper way to verify and validate that you have a good model?
Yeah, and so I'm going to get to this near the end, but I think it's through actual testing. I think it's through actually testing. I think there's a lot of things that we can do to build trust. I think there's a lot of things we can do to not build trust. And I think the next paper is pretty meaty when it comes to the models of trust with automation. But I think it comes down really to an individual situation is the problem. And so I think that's why like prototyping and user research are going to be really key when it comes to this type of stuff.
I had a question, Chris, since you mentioned aviation as in your slides earlier, and the human-computer interface automation for aviation. I'm curious to know whether any of the modern aviation technologies use deep neural networks.
I don't know. I don't necessarily think so. I think a lot of the things are very deterministic from a rule-based standpoint, but I'm not sure.
Okay. The second question I have is on the current slide that you have. When you talk of a robo, people are blindly following it. Are there any research which is happening where people are trying to use the principles behind GANs, generative adversarial networks, to apply to robots? So you have one robo which is showing in one direction, and another robo which is probably trying to correct what the first robo is doing.
Yeah, I mean, I think that this idea of like adversarial models in general is very interesting, but I would maybe think about it in a different way, right? Like I would love to build a model of what people consider trustworthy or not, and then use that to test situations or simulations for certain types of robot behavior, right? That would be very interesting. I mean, this is something where, we've started to build some interesting stuff around like converting from sketch to prototype or being able to monitor people using prototypes. And the interesting thing that's from there is that you can start to build models that would then simulate what a person would usually do from a usability situation. And that's, again, it's like you're building models that are playing against models. It's very interesting.
Okay, yeah, thanks.
Yeah. Cool. So this is the big one, like trust and automation. And so this one is about 101 papers, and it's from about 2002 to 2013. And so they have a very complicated way of talking about all of the different interactions that take place with trust. And I circled the three main things that they talk about are actually dispositional trust, situational trust, and then learned trust, which is broken up into two pieces where it's initial learned and dynamic learned. And so what this is meant to mean really is that there's a certain amount when people are going into the situation or into the interacting with the system, and they bring a lot of baggage, not baggage, but just like who they are to the situation. And then as they start to use it, they have other things that start to cause either increase or loss of trust. And so I'll go into these individually. So dispositional trust. This is an individual's enduring tendency to trust automation. And so that ends up being, you know, they've looked across all of the different papers that they saw around like age, gender, ethnicity, personality traits, and culture. And it seemed that age had a role in this. It seemed that culturally there was some role in it, but they were not able to do enough studies around it. Personality traits did have something to do with that. But again, like when I'm reading through this section of their paper, it was kind of murky. And it was really kind of made me feel like it's not, this is maybe a weaker version of it. Like unless you know that person in particular either usually trusts automation or they don't, it still felt like it was still very vague in this particular paper. The next one is situational trust. And so that depends on the specific context of an interaction. And in particular, there's internal variability, which means me as the user, and then external variability with regards to the situation that I'm actually utilizing the system. And so a lot of the internal factors they were talking about is things like self-confidence in general impacts this. Whether you're a subject matter expert, but not in the automation, but a subject matter expert in what the automation is trying to do or what a human would usually do in that situation, your mood, motivation, stress, sleep loss, and boredom. And so all these things would cause people to either trust things more or less. So like, you know, sleep loss was an interesting one because I think people would trust more if they were more tired because they wouldn't want to do the job, right? If they were bored, they would give up on trying to monitor the system as much. So that's very interesting. So that's internal to the person, right? What is their mind state? And this is maybe, you know, I don't go into theory of mind or some of these other things, but like how people can do like empathetic computing may really come in to help these types of factors or understand these factors to be able to adjust. And external factors were more like, what is the workload that comes with this type of automation? So is this just one screen out of like 20 when we talk about, say, like an aviation dashboard? Or is it that this is my main job and this is the only thing I'm focusing on? The complexity of the task. So is this like a piece of something that's bigger that requires a lot of work, or is this something that's very simple? And then the organizational setting. So who's telling me what to do? How do I, you know, kind of like, am I just a gig employee or am I an executive? Those have kind of an impact on these on this as well. And then learn trust. This is what I think when we talk about, a lot of the different literature talks a lot about how trust is something that is built over time, especially with people. And so I think that's where this is really related to that. And so based on past experience relevant to a specific automated system. And so this could mean that, you know, one, I'm bringing in kind of my initial perception of the system. It could be for a lot of different reasons that we'll just talk about, but then it's also like, as I use the system over time, how does it fail? How does it, you know, false positive, false negatives, which they call something like false alarms and misses, which it comes from the basically avionics. But when we talk about this now is that initial trust is really about this pre-existing knowledge. So what are my attitudes around this? What is the reputation within the world about this? What's my experience with system or similar technology? So if I've used other calculators that allow me to hit clear a bunch of times, well, I probably will hit clear here as well and have that expectation that it works. And then my understanding of actually how the system works at all. And then dynamic learned is that over time, right, things like my reliance on the system and then how the system performs during that is very key. So is it reliable? You know, the validity, predictability, dependability, timing of when errors happen, the difficulty of the error. So if something is a very easy thing for me to do, but the computer errors on it, I'll lose more trust than if it was something that would be difficult for me to do. The type of error, so whether it's a false alarm or a miss, or basically like a false positive or a false negative, can change that. And then usefulness in general, like how much does this actually help me in my day-to-day job? And from there, this is where we start to talk about design features where, you know, its appearance, ease of use, communication style, transparency, and level control. And this gets into what the recommendations are really for how to build things that are more trustworthy. And so I'll dive into that a little bit more. So appearance, in this case, there's a lot of discussion about anthropomorphism. So the idea of making robots seem more like humans. And so not only is it that they, would say you should maybe have a face that is trying to give the news, but that it should also be personalized. And so that means, the idea of either like ethnicity or gender or even temperament or trust, things like that could actually be important when it comes to the appearance of these systems, if they have an appearance at all, right? And so that's maybe why some of these papers are maybe even a little outdated, and what I think is most cutting edge is that kind of like great user experience, AI should in some cases and maybe most cases actually just blend into the background and shouldn't be visible at all. So I think that's one kind of interesting issue here. Ease of use. So how do you simplify down the experience to what really the core of it is? And then how do you improve, and in this case, basically reduce the number of false alarms and misses, or basically false positives and negatives. When it comes to communication style, we talk about the embodiment, which means like robotics, like how is it actually communicated from the machine or the robot in this case. They were talking a lot about, and then being polite, for example. Like it just seems that machines that are rude, even though it may cause some people, like so one example would be that people that are rude tend to be considered to be more intelligent. When it comes to robotics or when it comes to automation, that may not actually be the case. Transparency and feedback, and so this gets to the explainability and interpretability problem. And so how is it like ongoing as time goes on, because these systems are usually real time in some way. The interpretation, or how, like, going back to those mental models that we first talked about, what is my mental model of the system? And then how do you focus on, say, early and easy misses, and how do you recover from that? So recover trust from things that may be actually very simple. So what do you do next is very important when it comes to that. And so how transparent you are about that easy miss is one that could actually change the way people interpret the system a lot. And then finally, level of control. So when we talk about high automation, where it's off doing its own thing and there's very little human involvement, more transparency is actually better. And then finally, level of control based on user needs. So for some users, they need to be able to get in there and muck around with what is actually happening, and maybe where the automation or the AI or the machine learning can actually learn from people actively. But in other cases, there may not need that level of control. And so these are kind of some basic recommendations. So I'll pause for a second, and I'm going to go into now kind of like AI within organizations and some thoughts that I have about that, and then kind of in practice how we do things.
One of the things that strikes me as kind of interesting in looking at all these papers together is that you've got what seems to be 2 or 3 papers talking about how to improve or enhance trust between humans and robots, or humans and AI, humans and automation. And then you've got this other paper that's talking about how too much trust can be really dangerous.
Absolutely.
And, we can see examples of that in Uber, which you've mentioned, Tesla.
Yes.
And so how do you, do any of these papers try to synthesize all these things, or how do you synthesize all these things? Like appearance, it can either be a recommendation or a anti-recommendation. Should we make them look less human so that we trust them less, or does making them more human make them more or less? I think that the idea here was that making them look more human increases trust, but in the wrong situations, there's already the potential for too much trust.
That's right. I mean, I think in the case of, say, the robot that's trying to be an emergency service thing, a robot may not actually be appropriate for that use, right? It may be more appropriate to have one of the examples that Ayanna Howard brings up in that paper too is that people sometimes don't even know what a smoke alarm actually sounds like. And so they don't know if it's actually real or not even. So even like a very rudimentary kind of like things that are not in any way non-deterministic or automated in the way that we're talking about automation, like from an AI perspective, people don't even understand that, right? Like, and this is an issue when we talk about emergency services in general, is like, how do you build the right level of stress for someone to get out of the building rather than just hang out, right? So I think this is one of those things where it's about the right level of all of this stuff. So I don't think there's
challenges in finding the right level and balancing these factors.
That's right. Exactly.
Real quick on the subject of the emergency evacuation robot, there's a great anecdote that I heard on a walking tour at NASA Space Center in Port Canaveral, and it was at the first moon landing. I forget who was piloting the ship, but the automation was going to land them in a crater, and he actually overruled the automation and manually set it down.
Okay.
I don't know how true the story is. It was
I believe it.
The tour guide vouched for it, so I thought it was a cool story.
Well, maybe it was just flat enough there. You know what I mean? Like, I mean, talk about local maxima or something like that, right? Anyways, yeah, it's interesting. So what I wanted to talk about now is a little bit about
any more questions before Chris plows forward? All right.
Okay. Great. So I wanted to talk a little bit about AI in organizations, just because I think this is going to be key when we talk about how do you find that right level of trust. And so one of them is, and this is maybe a little bit of smattering of different thoughts that I've been thinking, but one, where do humans end and machines begin? And so there's a great article in National Review about how there was a survey that was done by some people at the Naval College. Again, there's still some questions about the how good the actual process of the survey was done, but they were saying that people will trust human, like basically fighter jets or bombers or other types of aeronautical vehicles with humans in them rather than drones. And part of the reason why is that, at least what they were saying in the survey, is that it's because this person is actually over the battlefield and they have some like skin in the game, so to speak. And so the thing is, though, is that it's not that there's not a human that's operating these things, right? Like there's a certain level of autonomy in all of these vehicles. It's just that there happens to be a meat bag sitting in one versus the meat bag is in Las Vegas. And so that was very interesting. My reference here about RoboCop, which, again, like I loved the original movie. The new one was not so great, but there was, and sorry, spoiler alert right now, but part of the discussion in this movie is that they found that even though they could give the human all of these kind of advanced capabilities, he was too slow in making decisions. And so they basically programmed it so that he felt like he was making decisions, but he actually wasn't. It was just the system doing it. And so where is that like level between the human and the machine in this case?
So that reminds me of there's this. I've never actually seen the paper, and it could be like it could be a myth, but I've heard it referenced many times. The idea being that that some research has been done that shows that I think it was research in building systems showed that humans need a certain amount of control or the feeling of control over their temperature. And so
interesting.
As a result, a lot of these office buildings have thermostats all over the place. They do absolutely nothing.
That's right. I've heard that too.
Really to kind of, facilitate humans feeling some control over the environment.
Absolutely. Absolutely. Well, that's what we want like, when you talk about what makes people feel good, it's like autonomy and control over your situation are two things that are really important. Right. So that's another thing I wanted to talk about is this idea of human in the loop or versus out of the loop machine learning and AI. And so this is from Chen-Hao Tan, where he talks about the differences between machine in the loop versus human in the loop. And so human in the loop is usually the machine makes some suggestions, the human either approves or gives feedback, and then the machine takes the final action. The idea of machine in the loop is more like assistive or augmentative AI machine learning, where the person gives context, gets suggestions, and then makes the final decision. And then there's this idea of like the loop, and this is a great talk by Brad at Stitch Fix, where this idea of that there's actually multiple systems that are existing out there, one of which is with the stylist, where they're getting recommendations for a particular person, and they're making decisions with that machine learning algorithm. And then the consumer is getting things, they're making decisions, sending things back. And there's it's not just this loop, but it's actually the warehouse system has that. They do sourcing in a way that allows them to predict maybe what would be popular next season, to then ask people to actually go and build those garments. And so it ends up looking much more like this, right? Rather than, and this is by Evelina Gabazova. And so she did this like really cool network graphs of all the different Star Wars movies. And, you know, this was very appropriate, right? Because it's a bunch of humans, it's a bunch of augmented humans like Darth Vader, but it's also androids, right? Or R2-D2 and C-3PO. And so this idea is that it's not longer going to be like a human and a machine talking to each other through a website or an app, but it's going to actually be the organization of people with a ecosystem of intelligences that are all interacting with each other. And then when we talk about like out of the loop, right? So this is from war games. And Whopper is kind of like this closed loop system that makes decisions on whether it should go to war or not, right? And that's considered to be the human out of the loop type of situation. But I think that, you know, when we talk about why AI or machine learning exists, it's for human purpose, right? So there shouldn't actually be any out of the loop processes. And I think this is maybe one of those cases where people have the wrong idea of where the system boundary is, because there's always a human that's impacted, even though, you know, when we talk about all of the bias in systems that are trying to do, say, loan approval, it's not so much, right, that that system exists by itself, right? It doesn't. It actually impacts humans' lives every day in what they do. And so if we don't consider that, that actually means that we're going to be building systems that are bad in some way. And then finally, accountability. And I found two other papers that I wanted to talk a little bit about. And so this is the case of, so if you imagine this was an autonomous vehicle, right? It was a pretty close call. And then there's this other truck. So it's like, this is actually from Reddit where it's like, I missed my exit. And so the autonomous vehicle is totally fine in this case, right? But the problem is that this responsibility is actually shifted to other human beings in this circumstance. And this is a paper that's called Moral Crumple Zones, which talks a lot about kind of like human-computer interaction and how when we talk about automation, we're usually actually foisting all of the problems onto the human rather than talking about it together. And the other issue is that this is an example of something called the Thurrock 25 machine, which is a special type of like radiology equipment to treat cancer. And so there was a problem where there was a type of fault that would happen when a radiologist would think they would give a dose, but what would happen is they would get an error on their screen, but in reality, the person that was on the bed got a dose. And there were a couple of people that died because of overdose of radiation. And so, you know, this is an amazing example of that. There were multiple problems that happened. There was a bad error message. The operator tried to redo the same thing over and over again. There was a mechanical locking system that changed between versions that would now allow this bad behavior to happen. And so in the end, we start to talk about what's accountability in this case, right? So this is a paper called Accountability in Computerized Society. And so like accountability can therefore be a powerful tool for motivating better practice and more trustworthy systems. So, you know, this idea of answerability and accountability and who actually owns this. In the case of the Thurrock 25, I think there were settlements, but there was a lot of finger pointing that like, whose problem was it? Right? And they tried to blame it on the operator, but it's actually everybody involved had a part. But this is where we get back into like complexity theory, right? Like it's very easy to see causal reasons after the fact. It's very hard to do so in advance. So that maybe gets us like, how do we do trust in practice then? And that's a very hard thing. So one of the things we do is we do a lot of prototyping, right? And when we talk about prototyping, I mean, this is actually a sketch file for a field service operations workflow tool that we created. And you can't see, you know, there's no like AI in here necessarily that you can see, but this idea of like recommended time frame, recommended parts, the fact that Patrick added description, different people are involved in this chat. Patrick is actually a bot in this case, by the way. But there's a lot of different machine learning algorithms that are doing prediction. There's certain types of AI that are making automatic decisions based on confidence levels. And so before we actually build any of those machine learning algorithms, we build a prototype and we talk to people about it. And I wanted to mention someone, Wendy Ju, who was at Stanford, is now at the Cornell. She's the head of design lab there. And so she does a lot of work with automotive right now. And so she does amazing work when it comes to faking a lot of systems. So you may have seen videos where it was like a trash can an autonomous trash can, like roving around, asking for people for trash. That was her work while she was at Stanford. But the thing is that trash can is actually, it's not autonomous in any way. It's actually controlled by a puppeteer. And so this is a system of what they call the WAS way, where they want to be able to test different types of head units and how to do interruption on the road. But it's all done by way of a human typing in the wizard interface. And then the car subsystem makes it sound like it's actually an autonomous vehicle that's talking to them. But they're recording all this so that they can then go back and look at this data and start to really learn from it. So I think, this idea, like very interesting ways to do prototyping, and this is maybe called the Wizard of Oz, right? And I've written a post about kind of the differences in expectations from people from something called the Concierge MVP versus the Wizard of Oz MVP, and I think there's some really valuable things there. And finally, it's like user interviews, right? So we talk about building this type of system. We then bring people into a room and we have them try it out, and we simulate a couple different things. We simulate correct operation. We simulate incorrect operation, including those false positives and false negatives. We get feedback from them to the machine and how they feel about that. And then we communicate state from the machine to the human. And we ask a lot of questions. So how did you feel about this action? How do you think the system decided this action? What does that mean? That's to get at their mental model. Do you trust these suggestions for what to do next? Was there enough information for you to take action? When would this fail? Like, what are the canonical stories that they know about that would actually not work in this case? Or how much do you trust the system to make the right decision in the future? Is it more or less than before, right? Like, how is that like initial versus dynamic trust, as we were talking about? How does that develop over time? Even though it's on a very short time scale over the course of this test, and then what would make you skeptical to use the system, right? And we do a lot of work here. So this is an example of one particular sprint we did where I think we interviewed 5 different people for one interface. And then we took all of these things and we actually put them on a scale of top is understood, bottom is not understood, right is positive sentiment, and left is negative sentiment. You start to see some groupings. So the things that are below the line tend to be things where we either need to do better change management, we need to get clarity in the UX, or change the amount of trust. We need to increase trust, or we need to increase explainability, interpretability. The things that are in the upper right-hand quadrant, those are things where people, it's the right amount of trust, right? They feel like they understand, they're interpreting things that are going on. And then funny enough, the stuff in the upper left-hand corner was mostly just around, they're concerned about the computer taking their job in this case, which, for this particular thing was valid, right? So anyways, I just wanted to say I'm from Philosopie. We offer a lot of different services around AI coaching and workshops and balanced team and even hackathons. So that's my piece. Sorry for running over there.
No, that was great. What questions do you all have?
I just have a quick observation. So when we talk of regulation, regulation will primarily be at 2 levels. One is at the government level and second would be at the domain level. For instance, if I'm selling an AI system to a hospital, the doctors need to be convinced that, my system is trustworthy. So it's much more complex probably than probably take time to solve.
Well, but that's the thing is that like whenever we build these systems, it's never just the person that uses it. And actually, the type of work we do when we're talking about enterprise work, like there's people that are the stakeholders that have to make the decision about making a purchasing decision. And so they need to trust it for certain reasons that may actually be opposed to the reasons why the actual operator would need to use it. And then there's also another person, which is the end consumer that in some way may be involved, right? So that's why like, I don't think it's as simple as like, just building a website anymore or just like training a model. And I mean, this is an example of where we do things like what's called rich picture. And so this is a way for us to understand the complexity of the situation. And anyways, I don't have time to go into this technique, but this is like a co-creation technique with the team to be able to identify all the different interactions and people that could be affected from an N order perspective.
Okay. Yeah. Great work, Chris.
Thank you. Yeah, I did want to talk about adversarial to whom. I love these adversarial examples, which I don't know if you know about the robot that got beat up in Philadelphia, but
no.
Or Pittsburgh. Yeah, so it was trying to hitchhike around the world. It hitchhiked across Canada without any issue. It got to Pittsburgh. Suddenly it's like on the side of the road, destroyed. But like, here's what I'd say is I I think, you know, there are a lot of adversarial examples that are bad, right? But there's some that are good. And so this is some really interesting work where for VR, using the way that the cicada of your eye works to be able to actually make people feel like they're walking straight when they're actually walking in a curve. And so the thing that's here is that that orange line is what they think they're walking and the blue line is what they're actually walking. So you can keep people contained to spaces, or even there's some great videos where they're like two people are actually being actively avoiding each other in the same space with VR goggles because they're using the same technique to make them avoid each other. So this idea of like adversarial examples towards humans as well, like there's a great paper that's about AI rationalization, and it gets to that point about what Stripe is doing. Like, what is a good enough technique to be interpretable or explainable? So anyways, it gets very meta at that point about what truth is and everything like that. But it's a very important discussion to have, I think, within the industry, right?
I think it's a very hot area of research right now, right? A lot of companies are looking into it very seriously in terms of any research papers which are new in this direction.
I mean, definitely like Ayanna Howard is doing a lot of the work there. Yeah. I think Wendy Ju is doing a lot of work there. I mean, there's lots of others too. I mean, okay. I think anybody that works, generally this is in the human-computer interaction field rather than the deep learning or machine learning fields. They're much more concerned on kind of like, are you building these tools that can learn faster or can understand with less evidence, right? Or generalize with less information. So it's outside of the machine learning and deep learning community, it seems.
Thanks.
You talked a little bit about having the meat bag in the plane, I guess.
Yeah.
Did you find that was just an effect on trust, or was it also improve the decision?
What do you mean by approve the decision? You mean about that particular study?
Yeah, I mean, did you find that those without the skin in the game, if you will, were taking more risks or things like that?
Yeah, that particular study does not actually talk to that at all, right? It's more about the perception of the people that are on the ground. And in all honesty, I mean, it didn't, I read 2 follow-up articles on a blog called War on the Rocks, which did some kind of like, they are a little bit against that survey because they believe it was not done exactly in the right way. But I think there's lots more research that should go into this, but like, it's not slowing down the deployment of drones in any way, right? If anything, drones are very effective when it comes to the types of things that the military wants to do. But, I guess, yeah, I don't have the information. I mean, the other thing I would say too is that like, when we talk about autonomous killing machines, there is actually a human in the loop, and that's probably the human that's getting killed, right? And so it's probably a bad idea in general. I mean, I don't know how we can actually build robots when we say we're ethical. I mean, and I don't mean to get on a soapbox, but I mean, ethics is really a human problem, right? And so from that standpoint, if we can't even believe that, say, corporations will act ethically, how do we believe that the machines that are going to be built will act ethically either?
I mean, you don't have to have someone in the ship to have a degree of accountability. There's other means to tie
that's
in.
Right. Yeah, there's chain of command also, which is another issue within, say, military, is how are orders given and executed, and then how are people allowed to disagree or not, right? Those are all very interesting aspects. Like, I'm betting you, well, yeah, I don't know if I'm betting you, but I would guess that there's maybe slightly different decision-making processes for people that are in the war theater versus people that are half a world away, and maybe those people that are half a world away are more likely to obey orders than those people that are going to try to be more contextual with their decision making. Maybe, I don't know. That's a really great question.
Potentially removes bad actors from the system, right? That's another benefit
of which type of thing?
Of having the skin in the game is it's a filter.
It could be, yeah, it could be either way, right? Like in some ways you could have I mean, that's the thing that's really interesting about machine learning is that because it's so good about anomalies, right? Or it's good about understanding breaks from generalization. That's where we'll really be able to understand like, what are the biases that we're maybe showing in this decision-making process? Are they biases that we're willing to accept? Because a lot of things like morality and ethics tend to be skewed by our biases to a certain extent. And so anyways, I'm just saying like, it's not as straightforward as like, this is good and this is bad, because we all are like a bundle of weird biases plus, are like, if you still believe in Freudian like psychology, the superego, ego and id are all kind of like fighting for control in our bodies at any moment. And so, yeah, it's a very tricky way to understand the world, but it's the reality of the world, right? Things are not clean, things are not easy.
All right. Well, Chris, thanks so much for
absolutely.
great presentation, and thanks everyone for your participation and great questions.
Thank you.
All righty. Take care. Have a great rest of the week.
Bye.
Thanks. Bye.